May 2024.
I'm inside the tornado.
A drone flies into the eye of a tornado.
Okay, it's roping out.
Yes.
If you come back if you need to.
It's the first time
stay in it.
it's ever been done.
It's just a beautiful dust bowl right now.
Gotcha.
So I kind of go through that condensation above, kind of drop down into the eye.
Do I need to come back? Should I come back?
Yeah, come back.
And you're seeing these like vortices spinning around. It was just like, is this real? Like, this is crazy.
That's Lewis Tucker. He and his younger brother, Nelson, didn't grow up storm chasing. They grew up almost nothing alike.
This was not in the cards for me.
One obsessed with drones, one obsessed with weather. But over a dinner table one night, those two different obsessions collided into something nobody thought was possible.
I was like, oh yeah, you could probably build a drone that could fly through a tornado. And he was like, really? Like all of science disagrees with that.
Science disagreed. They did it anyway.
It's the first time it had ever been done in history.
Today on Atmosphere, we're flying drones into tornadoes with Lewis Tucker of the OTUS Project. I'm meteorologist Emily Gracie, and this is Atmosphere, a podcast where science becomes conversation. Each week, I sit down with the experts behind the forecasts, the research, and the headlines to explore not just the science, but the human stories behind it. Through natural curiosity, we're making science more understandable, more relatable, and hopefully bringing a little more comfort in how we experience the world around us. If you're in the weather algorithm and you've spent any time on social media over the past year, there's a good chance you've seen them. These absolutely jaw-dropping videos of drones flying inside tornadoes. They're not CGI, they're not simulation, they're real footage captured by a team called the OTUS Project, which stands for Observations of Tornadoes by UAV Systems. OTUS is a self-funded nonprofit using custom-built drones and specialized sensors to get measurements from inside and around tornadoes, places where historically we've had a really hard time collecting data. The project was started by brothers Nelson and Lewis Tucker, and engineer Tanner Beard. And in 2024, they successfully flew a drone through a tornado for the first time. Since then, they've been continuing to push the technology, and their videos have gone viral, giving us all a pretty incredible look at the inside of these storms. But as amazing as the footage is, the goal here isn't to make cool videos. They're trying to answer some pretty fundamental questions about tornadoes. What are the winds actually doing near the surface? What's happening with the temperature, pressure, and humidity inside the storm? And can that information ultimately help us build better models and better warnings? Today on Atmosphere, I'm talking with Lewis Tucker, the co-founder and CEO of the OTUS Project, about what it's like to fly a drone into a tornado, what they've learned and what we still don't know, and what it feels like to watch your tiny aircraft disappear into one of nature's most powerful forces. Lewis Tucker, OTUS Project. I'm really excited to talk to you today because the images that you guys are putting out are unbelievable and have gone viral over the past year or so. So I can't wait to kind of dig in and hear about how this all came to be. Now, tell me, Lewis, what your role is with the OTUS Project.
So my role is I am technically the CEO. So I was one of the co-founders for the OTUS operation and handle a lot of things. So it's mostly keeping up on social media, keeping up with all the emails that we get. We get a lot of people that reaching out that want to help us out, a lot of fielding that. And then as well, just the field work and understanding, how can we allocate resources properly to do what we do? Because, it's quite a dynamic operation. There's a lot of moving pieces to flying drones inside of tornadoes. So just having all of that managed and organized is kind of my role.
And it's a family affair, right?
Yeah, there's 3 of us that are pretty heavily involved. Myself, my younger brother, Nelson, who I co-founded the project with, and then my dad as well, who's been helping us out.
Can you take me back to childhood? And were you guys doing stuff like this when you were kids with your dad? Just kind of these experimental projects?
No, this was not. This was not in the cards for me. I was thinking, what am I going to do when I grow up, or what am I going to do in 5 years? This was never really on the realm of possibility for me. Mainly because Delson and I just have very different interests, like on paper. So I was super into outdoor activities. I was really into drones, flying them around, getting to get outside and exploring the world. Nelson loved to stay inside. He loved the weather, but he loved more of the academic part of things. He'd be watching the news every night for the weather segment, and all these things. He was obsessed, and it was amazing as an older brother to see that. But I was like, man, we're pretty different. Flash forward, I guess, many years. We're in college, and I hadn't seen Nelson in a little while. But I was again super obsessed with drones. I had a pretty sizable drone racing career where I was semi-pro for a few years in college, and then kind of reconnected with him over weather science and what we could do to help actually better understand the atmosphere, and realizing that drones was the solution to that really kickstarted a lot of what we do at OTUS.
Okay, so at what point were you like, let's fly drones into tornadoes?
Yeah, this was like over dinner. Yeah, I ended up talking to Nelson. Hey, what's going on like with the weather? What are you learning? And he was just expressing me how many things that you just don't know about tornadoes. Can we actually get measurements near the surface to understand what's causing all this damage on the ground? Can we understand what's feeding the tornado with the thermodynamics around the tornado? And so he was kind of explaining these things to me. And I was like, oh yeah, you could probably build a drone that could fly through a tornado. And he was like, really? Like, all of science disagrees with that. I think there had been a paper that had just come out saying that it was, impossible. And I was like, no, like I have a friend who has a drone that goes over 200 miles an hour. Like, I think this is possible. He's like, really? And his eyes kind of lit up. And from there, we just kind of got the idea going. Initially, I knew, this is going to be quite an engineering undertaking to be able to design these drones, to build them, all the sensors that are required to put on the drones. It's actually the hardest part. It's not, in our perspective, it's not actually that hard to fly drones inside of tornadoes. It's really getting really good data that is so much harder because you're using a moving platform that's affected by the rotors. There's just so many dynamics going on. So ended up bringing on Tanner Beard, who is the chief engineer of the project right now. And he was a good friend of mine in drone racing. And the three of us really came together and actually, plotted it out. What would it actually look like to get a drone inside of a tornado? It had never been done. People have been trying for many years. And so we kind of over-engineered this entire system, and we were able to do it in 2024.
Going back to like the creation of this drone, and did you start with just one? And what was that like the first time you flew it? Was it like sending your baby off into a tornado and not knowing what's going to happen?
Yeah, definitely. There's some emotional attachment there. So for the first 2 years of the project, I did the drone building. So I definitely had some attachment there. I was like, my baby. Yeah, that's definitely a part of it. Whenever you fly the drone out, you don't know if you're getting it back. Thankfully, we've gotten it back almost every time. But the system that we initially came up with was very conservative to a degree. Like, we didn't know how the drone would react in the tornado. We didn't know what the effect of all the winds would be on it. And so we wanted to give the drone its best possible chance to get inside. So what we did is that we engineered a 2-drone system where we had a fixed wing drone that would carry the quadcopter drone on the bottom. And we would throw the fixed wing to the tornado, and it would carry that smaller, more aerodynamic drone to the tornado. It would drop it off, and then that small drone would go into the tornado. And we did that because we didn't know how much battery life that we would have with the small drone, because racing drones have a really limited battery life. Like in that sport, it's like you could get maybe a minute and a half, which is a flight time, which is really short to some people. They're like, what? Like, I thought you can get half an hour. But it really depends on how capable your drone is. The faster that it can fly, generally, the much shorter its flight time is. So we wanted to have a drone that had decent flight time, like maybe 5 minutes, or maybe even 10 minutes. But we didn't know how long it would take to get to the tornado. And then by the time it got there, the battery could be dead. So we engineered this 2-drone system that ended up being pretty complicated. just because flying a fixed wing, in these high winds can be quite a challenge. You have to throw the wing, and we can't, be hitting power lines or anything along the road when we're doing that. So there's just a lot of factors there. But the system ended up ultimately working. But ever since we've really slimmed it down, now that we know more about what we're doing, we kind of eliminated that whole fixed wing part of it, just because it takes so long to set up and to deploy. So right now we're just using quadcopters that are just becoming a little bit more capable every year.
How many do you have, like, at any one time?
This year we got up to around 15, and we were ready for some opportunities that didn't really present themselves, at least in 2026. There were a lot of really good opportunities in 2025. And what I mean by that is like long-lived tornadoes that are highly visible. They're not moving super fast, so you can catch up to them, and you can kind of deploy more from one spot. But this year was really difficult. We did have some really great intercepts. I'm sure people have seen online, but it wasn't. It was just much trickier. There were a lot more rain-wrapped tornadoes, a lot of tornadoes that were in trees, in areas that were hard to reach. So it was very dynamic.
So there's this whole drone portion, but then there's this portion like you're kind of hinting at now, which is storm chasing, which you have to get to the tornado. So I'm guessing that's where your brother comes in. And does he map out a plan for storm chasing? And then also I'm curious what your thoughts on storm chasing are, because usually the non-meteorologist, non-storm chaser is like, are you nuts? Why are we hunting down a tornado?
Right. I'm a little bit of a adrenaline junkie, you could say. So it actually fits me quite well. It is actually fascinating because the whole reason why the OTUS is storm chasing is not because it's for love of storm chasing, which is very rare. For us, it was way more academic. Like, we wanted to actually go and help understand what's going on in the atmosphere. And that's why we started this whole project and have been storm chasing. And with that, I think it provides a pretty cool perspective. Because again, we're not doing this for show. Like, we'll release videos online and show people what we're doing, but that's not really the point of it. It's really about understanding the atmosphere. And that can honestly lend itself to a lot of headache and challenges, because as a regular storm chaser, you're just going out there in your car and getting to see the weather. But we're always stressing about, are the drones perfectly working? Is our data right? Have we factored out all of these things going into the data? Have our sensors cleaned off and ready to go? Like, there's just so much overhead there, but I mean, we think it's all worth it. So.
Yeah. So tell me about the data and where it's going. Who are you partnering with? What kind of data is being collected?
So we're collecting temperature, pressure, relative humidity, and depending on the drone, experimental wind speed. So wind speed to us is probably the most fascinating, because it is just like no one knows what the wind speeds are near the surface in a tornado. It's never, especially the vertical component of wind. Like, there's just never been a measurement on it. We have maybe a kind of a general idea for what that is, but we really don't. And so we initially started working with NIST, the National Institute for Standards and Technology, and they were specifically interested in that component of wind. And because for them, they are helping with writing the building codes that goes into making homes safer throughout the U.S. And they're very interested in what is actually causing this damage to these houses. So that way we can better design homes. We can put that into law. So they've been very gracious to us. They've been giving us some wind tunnel time and maybe a little bit of financial contribution to try to develop these wind sensors. And that's been great. We've also been working with Josh and Karen Kasiba, the Dows with Farm. And they are not actually very interested in wind speed. They're very interested in the thermodynamics and what's feeding the tornado. So a lot of the data that we've been getting with the thermo, we've been giving over to them, and they've been using to help kind of understand what's going on. And with them, like, they really want data in conjunction with radar measurements. So that way that they can kind of cross-correlate, what's going on here. And then we've also been having some other informal collaborations with NSSL specifically. My brother is actually going to Texas Tech this fall. He's there right now. He just moved down to work with their university and to try to help figure out more of the engineering piece of it's pretty similar with NIST of like, what are the wind speeds going on? How can we use that to help, with better design? They also have their own mobile radar program. So we may be integrated with them. So yeah, there's a lot of different organizations out there that are very interested in what we do. We kind of launched at the worst time. Unfortunately, when we did kind of get started with this project, a lot of funding dried up. There was a lot of promise of research funding and opportunities there, but that really dried up very quickly. And so a lot of other organizations have just been trying to survive, just as we have. So we would like to get fully integrated with one, but we're still kind of working towards getting there.
The initial idea of the drone flying into tornadoes, were you aware of what was being used in hurricanes at that point and the importance of like that near the surface data that was previously unknown? Like, did any ideas spawn from the hurricane work that's been done?
Yeah, I would say that's been a really interesting science. It is. Tornadoes it's like a whole another animal. So for us with our designs and how we've structured things, it's not very similar, but you can definitely draw parallels to that. They're dropping modified munitions and stuff that have all these sensors on them, and they're dropping them over the sea, but they're not actually able to get measurements really over land. And so that's actually something that we've been thinking about with other teams is how do we actually use this on hurricanes too. So we've actually been working with Josh and Karen Castillo on that too, because they're going to be doing a hurricane deployment this year if we get a hurricane, and we might be out there too. So yeah, there's definitely some parallels there, but a little different.
Okay, so take me through like a day where you guys are like, all right, today's the day we're going to deploy a drone, hopefully into a tornado.
So it really starts almost a week out. It depends on the setup, but there's so much forecasting that goes into what we do. I have so much more of a appreciation for that than I used to when we first got started. Back in 2024, I had never storm chased before, and really, I think took a lot of that for granted, all of the forecasting work. And as well with some tornadoes that we've gotten this year, there were actually a lot of times where the models didn't have anything happening. But Nelson saw the environment and he saw different soundings and he kind of put the pieces together and was able to make decisions to go to places that the models didn't have anything happening at. And we were able to get tornadoes. So there's really a lot of also manual meteorology that goes on, with there being less balloon launches and data collection in the atmosphere right now. You have to do more of that heavy lifting to try to really get there. So that's a lot of the work that goes, from 7 days out to maybe 3 to 2 days out. And then from there, it's really, specifying your location. So in general, what we do is the night before that there's going to be a setup, we will drive out to that state, that general area. And then really it's that morning, once you get some either, convection in the morning, or you have like an MCS that rolls through, or whatever happens, then the models have a better idea for that day, what's going to happen. You just kind of narrow it down until you get to that tornadic storm. So.
Okay. So then a tornado starts to appear. What happens next?
That's always the fun part. Hopefully the tornado starts to appear on your storm. Otherwise, if not, then, all hell breaks loose and you're like, all right, what do we do now? Do we stay on the storm that we like, that we think could also produce, or do we go to another storm? Do we go to the other storm that is producing? So there's a lot of these things going on in real time. We'll start to position ourselves under the mesocyclone. We will generally deploy once we see a pretty defined funnel. Like at that point, we are booting up everything. We're getting all the drones ready, fully, charged up, ready to go. All of our systems, we're testing them constantly to make sure that everything's working at the time. And then it's really once we see ground circulation. If we see any ground circulation, that's when we launch the drones. We've gotten it to a point where we can launch and come back right away and keep going, but it's still like we have to pull over. It's a little bit of a process. So we don't want to get behind the storm by deploying too much. So we definitely try to deploy sparingly and do it when we feel like that there's a good chance that there's going to be a tornado. It's going to be on the ground for a little while. And you can kind of just see that in the atmosphere when it's happening. You can see a pretty defined wall cloud, a pretty defined RFD cut, something that's wrapping around. A lot of these different properties. You can just kind of look at the low levels. How are the winds around you? How is that working out? Like there's just all these different factors that you kind of consider, and then we make the call in the moment to deploy.
It appears from the videos that you were staying in the car the whole time. Is that true?
Yes, we've done both this year. So we developed a system where we could fly from inside the vehicle using antenna trackers. So we moved our antennas up above the car. Because if we fly from inside the car and our antennas are in the car, then our connection is not too great. Because cars are metal boxes, right? So we this year try to get our antennas up on the roof, but that also lends itself to challenges because you're exposing everything to the elements, high winds. We had these antenna trackers where it was actually pointing the antennas at the drone in real time in the tornado, so we get really good connection. That system ultimately, I think it was something that we developed very quickly and on the fly. So there were some bugs and issues with it that Tanner was going through. And so, yeah, it really just depended on the day when things were working. At least towards the end of the season, we ended up just going back to what we had done in 2025, which is more old fashioned, where we're pulling the car over, we're getting out of the car, we're using like the standard FPV system, which is like these FPV goggles. We're using our transmitter, and we're just stepping outside the vehicle and being removed from that, and then just having a direct line of sight with the tornado.
It almost seems like a safer way to storm chase because you have to be at a certain distance, right? Like other storm chasers are driving into the tornado and launching things like rockets and stuff.
Right. Launching things. Whatever those things are. That is true. Yeah, it's kind of, it actually is safer to be in the vehicle if possible, just because you want to be mobile. So like we had a time in 2024, same day as the Greenfield, Iowa day. If you've heard of that one of the strongest tornadoes, tornadic wind speeds that have ever been measured. We were on the kind of sister tornado, on the Carbon, Iowa tornado. And we got out of the car, deployed. Then Eric was realizing, and he's a professional storm chaser on the team. He was like, hey, this tornado is coming straight at us. And there's also another tornado forming to our south, which ended up being Greenfield. And so we were kind of in a difficult spot, and we had to abandon the drone flight. And I was really close to getting inside the tornado. Even to this day, probably would have been one of our best intercepts ever, but decided just due to safety that we had to get out, and we had to drive away. So if there's a way where we can drive and fly, it actually makes for it to, so we can get a little bit closer to the tornado, have better signal, and then still be able to move around. But we're just a lot more limited when we do have to get out of the car.
Do you ever get nervous? Because the way that you appear to be almost blinded, when you're flying a drone to like what's going on immediately around you. Do you have to really trust like your team members to keep you safe in that time?
Yeah, this was a decision I made, back when we first started. I just told myself, I'm going to trust Eric and the team. I'm going to trust people who know weather, that they're going to make the right call. And I just don't have any bandwidth to worry about that. Like I just need to kind of give up that to them because they're the experts. Eric Fox has been doing this for decades. And so I knew that we were in the right hands. It is interesting when you're flying drones into tornadoes because you are getting all of the input, into your ears from around you in the car. Everyone's shouting different things. And you're meanwhile like one with the drone in the tornado. So you do have to like hold both realities together at once. And that's like kind of a skill that I think you can develop over time. And this is something that I developed through racing drones, where you're like really locked in on being kind of one with the drone, but then you're also kind of aware of the environment and people telling you things. But it can be pretty chaotic as the pilot trying to make the right call at the right time, because there's split-second decisions that can, decide whether or not that was a successful day or not, or season. So there's a lot of pressure there.
The first time I saw one of the OTUS videos, my initial reaction was, how is this thing surviving? So how is it survive? Like the wind speeds in tornadoes are crazy. And how is something as small as a drone actually surviving those elements?
There's a combination of factors. So, you need to survive the tornado. So your drone needs to be durable. It needs to have the electronics inside protected well. But also, it needs to be able to overcome those wind speeds and overcome debris in the air, all the different dynamics. It needs to fly in rain. You need to be able to fly when sometimes it's really hard to see because you're flying into a cloud sometimes. At least ideally, you're flying into a condensated tornado. Um, and so, yeah, that's a huge design challenge, but that's something that we've generally overcome. So how we do it is we try to get the drone as small as possible, because the smaller the drone, the less it can get thrown around and manipulated in the air. Then we choose really powerful motors that are way more powerful than what you see on commercial drones that people fly around around their house. And then we also have propellers on the drone that can really cut through the air well. And it's just a factor of having a really small, light, powerful drone that can be able to fight those winds. That's how you're actually able to fly inside these tornadoes. And then what we also do is that we have a 3D printed filament shell that is super durable. It's called TPU filament. We use that in drone racing all the time because it is super durable and flexible. So it's able to have a little bit of give, but it really won't let anything through. We use a carbon fiber frame just because it's really light and strong. And so we do everything that we can to make the drones super durable. And this is a whole thing in drone racing. Like the drones in drone racing can pull up to 15 G's in turns. So they're meant to experience extreme forces. And so we just use a lot of that knowledge and put that into this.
I wonder if, and I know nothing about aerospace engineering, but the future of airplanes in a more turbulent atmosphere, if they can utilize this sort of, tactics that you've taken into account here.
I think you're seeing a lot of this in, the future of drones, maybe bigger drones like flying cars or, whatever is kind of on the frontier right now in aerospace. You're definitely seeing a lot of this just because the materials are getting better. You're able to 3D print things in a way that you weren't able to do before. That can just be useful for the inside of the drone. It's even just for our sensors, we've been using a lot of 3D printed components. You can design everything on the software, turn to your left and print it on a 3D printer in your room. So the access to a lot of these kind of materials has been a huge game changer. Yeah, for sure.
Did you watch October Sky as a kid?
I did not.
Twister, were any of these movies inspirational to you?
I never watched Twister until after I had already seen Twisters.
Oh my gosh.
To me, weather was really Nelson's thing. That was my younger brother's thing, and I wanted that to be his. So I'd never been super into the weather. I will say, I definitely had gone on my own lightning chases because I do really like lightning. So there have been a few times at home where when we're on vacation, I had kind of gone off and looked at the lightning, and I definitely have a huge appreciation for nature, and that definitely shines through with this for sure.
The other thing that really surprised me when I saw some of these videos were what the inside of a tornado looks like. I guess I mean, nobody had any idea, but some of these shots where you fly in and you get these 360 views where you're looking up and down into the inside of this thing, that was mind-blowing to me. And I'm curious, you and your team, what was the first time you saw the inside of a tornado? What was the reaction of the team?
It's funny because we'll usually have a monitor system set up where the rest of the team can see what's going on. But sometimes either there was, a cable that was pulled out or something, and it's just the pilot, it's experiencing this. And you're having, as the pilot, to relay this to the rest of the team. The first time we ever flew a drone inside of a tornado. It's the first time it had ever been done in history. This was back in May 2024. And I was the one who did that flight, and it was just unbelievable. Because how we had done that flight, and we still haven't actually fully released it, but we had a tornado that was pretty condensated above and then had a lot of multi-vortices on the ground. So I kind of go through that condensation above, kind of drop down into the eye, and you're seeing these vortices spinning around the drone as I drop down into it. And it was just is this real? This is crazy. And it's what was also funny about that and very just fun about that experience was that I had not done that much storm chasing up until that point. And that whole week I was like, guys, like there's totally like an eye to a tornado, right? And Nelson and Eric were like, no, like they both like that's kind of a thing, but like not really, like because it's complicated. And I was like, no, like there's definitely some clear center in the middle of a tornado. Um, just like based on what I'd seen in movies or whatever. And then I actually fly into it. And then in this case, there was kind of a clear center. And I was like, see guys, like, um, so that was just like a fun, humorous moment for us. But yeah, I mean, every tornado is so different. Like, I'm sure you've seen some of our intercepts this year. Like, for example, Jeffersonville, Illinois. Um, that tornado was almost just like straight vertical winds. So there really wasn't an eye in that tornado. It's just some condensation. There's some multi-vortices kind of going around. But then in other tornadoes like Wyoming, Iowa is an example. That was one of our first deployments of the season. I think that's actually our most viewed tornado intercept by far. I think it did about 60 million, but like that one, they had these rings in the tornado. Like I was kind of flabbergasted when I like went into it. I was like, I'd never seen that before. Like different rings and almost looked like a hurricane in some spots. Like that one was really fascinating. And there's just, so many different kinds of tornadic flow, many different kinds of tornadoes. It's not very simple. Like you can't just fly drone into a tornado and then understand tornadoes because there's so many different kinds that form for different reasons.
How does it feel? And are you fully aware of like kind of the history making going on here and the views that you're providing and the scientists watching this and what they're learning from it?
Yeah, it's incredible. I try to not get too excited in the moment. Like I'm sure people on the team would also like, comment on that. Like I generally like to try to stay as focused as I can on the mission, and not try to, get too distracted from that just because it's so dynamic and so involved. Like you really need to make split second decisions, whether or not for safety or just, to get really good data. There's definitely some times where I've been flying around and I'm like, this has really never been documented before and it's spectacular. Like one example of that would be last year I flew into a tornado in Crowder, Missouri. It was actually our second ever tornado intercept, and it went over a very small town. It was like a neighborhood, and it actually started causing fires and destroying buildings and downing power lines. And I was like, wow, I'm flying in the tornado as it's causing this destruction. Like to me, that was such a huge moment because then, I was just thinking about, how can we use what I captured on the drone with the data to be able to help kind of correlate that to what was being caused on the ground. And maybe we could help better understand like what was going on.
Is it ever like sobering or eye-opening as far as like when you think about the people that are actually being impacted? And yes, tornadoes are fun and exciting and this is adrenaline, but also like they're killing people. When you start to fly into a tornado, are you ever concerned about what you might see?
Yeah, totally. And in that example that I just brought up in Crowder, Missouri, like I think that's why it stuck out to me so much and why it was so, top of mind, just because, you're seeing a tornado going for homes and buildings and you're like, I really hope that, people are sheltered. Thankfully, I think the tornado wasn't too strong. So I was feeling a little bit better about that. But yeah, I mean, there's always a risk there. With how we operate, we really don't want to fly that much over structures and buildings and houses. We want to, because in case we have anything wrong happen to the drone, we don't want people to be in harm's way. So we've never really intercepted over many structures or buildings. It's really mainly been open fields and whatnot. But we do have those situations, where there are houses that are affected by these tornadoes. And that's always a risk. And so that's something that you kind of have to mentally prepare yourself for, is like, you may see something that's like really, really hard to watch. And so, that's why it's just so important to be focused on your mission and also kind of always know like why you're doing it. A lot of people storm chase, just for the thrill. There are people that storm chase to actually help, people get out of harm's way. And that's really amazing. And yeah, with what we're doing, we're storm chasing to really help save lives, to help build better structures and buildings, and really help with warnings, because warnings can be all over the place. There can be a tornado warning and there's no tornado threat, or there can be a tornado and there's no tornado warning. So there's so many reasons why, that we're doing this. And it's those kind of sobering moments that kind of bring us back to that.
Okay, so what's next? Like, what are goals for 2027 and beyond? What are you guys hoping to do? Like, limitless funds, what do you want to do?
Our main goal is how can we measure tornadoes that can be used in, real science? How do we actually progress understanding? How do we help with modeling? There's so many new technologies with AI and modeling and all that hasn't really, been applied in our opinion to the weather space yet, just because it's a data problem. Like if you don't have the data, you can't do a better job with interpreting it. And so, we really want to get good data next year and in years to come. The main way to do that, we think, is through really like science funding, grant funding. We've just been trying to keep ourselves afloat through posting about things online, getting sponsors. We need to fly 50 drones. We need to really get good data sets so we can be able to help really have a good grasp of what's going on. That's our main goal right now, is partnering with these organizations in more of a formal way, actually getting funding through them and the ability to have our data be processed by those people. Because we're not necessarily data scientists. We're trying to do what we can to get good data and to do all that right. But that's a whole field and entire academic study is, understanding this data. So, but yeah, it takes a lot of resources to be able to really pull this off.
Well, Lewis, is there anything else you want to add about the OTUS project or the work that you're doing?
This is really group effort. I don't get paid to do this, although I'm doing it full time. We are really putting everything into this and self-funding the whole thing. So if anyone's listening out there that wants to either help join the team in certain capacities, whether it's with the drones or whether it's with social media or anything like that, feel free to reach out to us. You just visit our website, and then anything related to funding, feel free to let us know. So thank you so much, Emily, for having me on. This is a really great conversation.
For sure. Thanks, Lewis. Thank you to Lewis Tucker from OTUS for joining me on this episode of Atmosphere. If you're interested in partnering with OTUS or looking at any of their really cool videos, you can find them on YouTube, and you can find their contact information on their website, theotusproject.com. If today's episode sparked any questions, or if you just want to talk weather, you can connect with me on Facebook. I'm meteorologist Emily Gracie, or follow along on Instagram at Atmosphere Podcast. For those who like to go beyond the audio, I'm also publishing deeper dives, episode recaps, and extra content every week over on Substack. If that sounds like your thing, I'd love for you to subscribe and join that community there. If you enjoyed this conversation, taking a second to follow Atmosphere on YouTube, Spotify, or Apple ensures that you won't miss the next one. Leaving a rating or review can also make a huge difference in helping new listeners find the show. And if you know someone who loves science, sharing an episode with them is the best support you can give. Atmosphere is a production of Mike Burst. It's produced and edited by me, Emily Gracie. If you're looking for even more weather updates, check out Weekly Weather Brief. It's a fast-paced rundown of the week's top weather and science stories that I co-host with fellow meteorologist Karen Jerriman. New episodes drop every Friday on YouTube, Spotify, and Apple Podcasts. I'm meteorologist Emily Gracie. Thanks for taking the time to slow down, stay curious, and explore the atmosphere.